This is an electrical demonstrator. It has an electrical circuit that includes many components used on Caterpillar vehicles or with Caterpillar engines. It will help teach you to troubleshoot common vehicle electrical system problems. A drawing furnished with this videotape shows the same circuit. Use it to follow the checks made during this presentation. Many electrical system checks can be made with the 5P300 electrical tester. Videotape 49 explains how the tester is used. The actual wiring is behind this panel, but the lines represent current flow as depicted on the schematic drawing. The bolt heads are test points where voltage checks can be made. Circuits and components can be made inoperative by means of hidden switches. By making voltage checks, we can locate most faults. Our test apparatus will consist simply of a bulb that works at system voltage. Leads soldered to it connect to a prod and a clip. The first complaint is that the vehicle will not start. We turn the switch to start the engine, and nothing happens. We begin to check by making sure the disconnect switch is on. We will leave it on for all tests. The source of voltage is the battery that is represented by this box. We put the lamp clip on the negative terminal. The other bulb connection is made through the prod. Touch the positive battery terminal, and the bulb lights. If we follow the circuit from the battery, the bulb should light at every test point. The circuit is continuous to here. At the other side of the circuit breaker, we still have voltage. The circuit breaker is good. Here, the bulb fails to light. The circuit is broken. We have replaced the wire that was broken between the two test points and test again. Now we have voltage here. The wire is okay, and we can continue checking. The circuit is all right past the ammeter, and we follow the wire that goes to the heat start switch. Voltage is getting to the switch. The switch is all right too. The broken wire was the only problem. This time we'll go directly to the problem. We check ahead of the heat start switch, and we have voltage. Now, we put the prod on the heat terminal and turn the switch to heat. There is no light, so voltage is not going through the switch. We know the switch is bad. A good switch would let voltage go to the relay. But we have no voltage here. We replace the heat start switch and test again. This time we get voltage at the relay. We can check beyond the relay at the glow plug. It is also getting voltage. This test does not tell us that the glow plug is working, however. We can use the electrical tester to test the current drawn by the plug. The power leads are connected to the battery, and the clamp-on ammeter clamped around the glow plug with the arrow facing in the direction of the current flow. The bottom ammeter scale shows current draw when the switch is turned to heat. With practice, you can isolate the problem quickly. This complaint is that the starting motor won't work. When we turn the switch to start, nothing happens. A test ahead of the switch shows that there is voltage to the switch. We next test the start terminal of the switch for voltage. There is no voltage. This time, instead of replacing the switch immediately, we'll first use a jumper wire across the terminals. The starting motor runs. It is only the heat start switch that is bad. A solenoid valve like this controls fuel flow to most truck engines. A key-type ignition switch closes the circuit and supplies voltage to the solenoid fuel valve. With the switch on, we can begin troubleshooting at the valve and work back until we find the problem. There's no voltage here. We follow the circuit back to the ignition switch. There's no voltage here. There is voltage here, so the switch must be bad. We can use the jumper again to bypass the switch. We hear the solenoid valve open when we connect the jumper. A check with the test light shows we have voltage in the circuit to the valve. If we replace the ignition switch, the fuel problem will be corrected. In this simulated test, the engine is running and the alternator should be charging the battery. However, either the alternator or the regulator could be responsible for not charging. How do we tell which one is defective? The vehicle ammeter shows no charge. It could also be bad, but we will presume that it is good. We need the electrical tester to test the charging circuit. There are two leads called field leads and a field control switch that we will use. First, we have to disconnect the regulator wire from the F1 terminal, and we'll simulate the disconnecting this way. Now clamp the blue or dark-colored clip to the alternator's F1 terminal and the yellow or light-colored clip to the alternator battery terminal. Run the engine and push the field control switch to on. You must hold it. The vehicle ammeter now shows a charge. The fault is in the regulator, not the alternator. Replace the regulator. Test procedures and observe the precautions given in the special instruction. We've shown you only a few common faults you might find in an electrical circuit. Now, try to solve the written problems that come with this videotape.